What's up, guys? This is C-Squared Mathematics. Mr. Carlson here, and we are going to be learning about polar graphs using a Desmos activity. So I really like this Desmos activity because it basically explains all the math informally, like without any of the data or the obnoxious math equations. And then tomorrow, what we're going to be doing is 7.4 polar graphs, the actual formal mathematical equations of what makes these graphs. So the previous couple of days, what we did was polar coordinates, and then we expanded upon that, and then we learned about polar equations and how to convert between rectangular and polar. So those polar equations specifically have different shapes. Depending on what the polar equation is dependent upon what the rectangular conversion of it is. And often the rectangular conversion of it is sometimes very familiar to us, like circles, but oftentimes they're very different and very unique, something that we've probably never seen on a graph before. So that's why I like going through this Desmos activity. I'm only going to go through it a little bit for it with you because I really want you to explore it on your own. But before we do that, let's go through 2 questions of bell work at least, get you on the homework quiz, and then the actual lesson closure homework summary. So these 2 questions are what I have on bell work. These questions are great questions to help you prepare for the homework quiz. So go ahead and pause the video if you need to and get these down. The first one, what I want to do is convert the rectangular to polar. So on this one, I'm going from rectangular to polar here, okay? And I need to use the formulas or the steps that we learned yesterday to get there, which means I need to know these 2 formulas. For one, I need to know that x equals r times cosine of theta. I also need to know that y equals r times sine of theta. Now, we did something similar to this during the video yesterday. And what I said here is that it's probably best if you actually simplify this out first, which means FOIL it out. So I'm going to FOIL this out. This is x squared minus 16x plus 64, then plus y squared equals 64. Now what happens is the 64s do definitely go poofy. And then what also happens is I'm going to actually substitute my x's for my y cosines and my y for my r sines. So what's going to happen is this. I have r times cosine of theta squared minus 16 times r cosine of theta, just substituting x for r cosine theta. And then y squared would be y plus y. Sorry, y squared is plus r squared. But before we do that, let's just do r and then sine of theta. But make sure you square it. And then, of course, this is equal to 0. I'm going to continue the work up here. So what is this going to equal? This is r squared and then times cosine squared theta. Plus, I'm going to rearrange just slightly here. R squared sine squared theta. I'm just rearranging this term, moving it over. Minus 16 and then r cosine theta equals 0. Now, why did I do that? Because if I take an r squared out, what I get then is just cosine squared theta plus sine squared theta, which we all know from the Pythagorean identity is 1, okay? Because again, you must be cosine squared theta, I'm sine squared theta, and together we can be 1, right? So that's what it is. So that means that all that is that leaves me with r squared times 1, okay? And then all the rest of this. Now, when I'm given this, I can actually factor out an r. So I'm going to factor out that r. What's left is r minus 16 and then cosine theta. And then I set each one of these equal to 0. So this one equal to 0, r equals 0, but that doesn't give me anything worth my while. But this is the actual equation that I want. Once I set it equal to 0 and solve for r, I get r equals 16 cosine theta. And that is my final answer. Okay? So, a preview for what we're going to be doing today. Look at this. This is a circle. And then look at this. What kind of equation did I get here? Okay, so think about this type of equation, this type of polar equation, and then look at the circle that we had. Okay, eventually we'll probably get really, really good at bouncing back and forth between polar equations and rectangular equations just by the sheer practice and by looking at it. So for instance, this one right here, since it's sine, and since this is 14, I'm just going to take half of that. I already know that it's going to be a circle with something with 7 and probably something with my y coordinates, mixing with my y coordinates because sine is y. So when I'm looking at this one, if I want to go from rectangular to, or polar to rectangular, what I'm now going to do is use similar formulas that I used up here, but not completely similar formulas. So in one sense, I'm going to basically manipulate this to get to my rectangular equations. But before I actually manipulate it, I think a good thing for us to do is simply recognize that this sine of theta, this actually equals y all over r. So I'm going to say r equals negative 14. Sine of theta equals y all over r. Now I'm going to times each side by r so I can get rid of my denominator here. Now I have negative 14 times y. Now what I can do is say, okay, r squared. Fantastic. What is r squared? So first I just took sine of theta equals y all over r. I multiplied each side by r here. Those went poofy, got r squared. And now what I can do is look at the r squared, and that r squared is just x squared plus y squared. And if I add the 14y over, I get this. And so this is actually starting to look almost like a circle. And the way it would look like a circle is if I actually complete the square on this. So that's what I'm going to do. So this is x squared plus y squared plus 14, and then plus something, and then whatever I do to one side, I must do to the other. So if I add something to the left side, I need to do the same something to the right side. What is that? Well, that is the b divided by 2, and then I square it. So 14 divided by 2 is 7. I square that, and that gives me 49. This gives me 49. And now what I have is x squared plus y plus 7. Factor that perfect trinomial. If you don't know where 7 comes from, just take the b term divided by 2, and that's the 7. That's where it comes from. 14 divided by 2 is 7. Take the b term, a, b, c. B term, 14 divided by 2 gives me 7. Equals 49. And then this is my final answer. Now it does say use the rectangular coordinate system to graph the rectangular equation. How do I graph that? Well, this tells me that my r is 7 because r squared is this, 14. That's my actual formula for a circle. If you guys remember, my formula for a circle is x minus h squared plus y minus k squared equals r squared. This is my formula for a circle. H and k are my center, and r is my radius. So that means if this is 49, I square root that, that gives me my radius. And my center here equals 0 and then negative 7. Notice how there's a built-in negative here? So if that's positive, that means that needs to be negative. So it cancels it out. So I would use this information to actually plot this rectangular equation, the circle, onto my rectangular plane. Okay? Pretty interesting, right? You can kind of go back and forth. And same thing here. Notice how this was cosine, and then I was affecting the x's here. This was sine, and I was affecting the y's here. Yes? It's pretty nifty, I think. Very nifty indeed. I really like it. Sweet. Okay. Let's erase this and move on. So, homework quiz is going to be 25 minutes, 5 questions. Okay, this is your last homework quiz for the week. You're not going to have a 7.4 polar graphs homework quiz for tomorrow because you'll actually have a quiz on Friday. Okay, but again, it's just optional. Once you're done, or if you're not going to do this, go to student.desmos.com, begin the Desmos activity, And here's the code. Y equals F9 C9. C9 3. So basically what this Desmos activity is going to do is it's going to explore 4 different curves from polar graphs. Number 1, circles, which we are very familiar with. We should be very familiar with, and we went through those during the bell work. We had 2 circles there, circle equations. So circles, roses, limosans, that's how I pronounce it, limosans, and then also what we call lemniscates. Okay, I don't know, I can't remember if I put lemniscates on here, but we definitely will go through that tomorrow. Okay, so no prior knowledge of polar graphs is assumed. We're just going to have fun going to town. So you should get on this. Here it is again. You can pause the screen and go to town. And it's also on Google Classroom. Just click on the link on the week 7 suggested outline template. Okay, so first things first, I love polar graphs. I really do like polar graphs, and you should love polar graphs too, because these are what polar graphs can make. I mean, this is really beautiful stuff. So this equation right here is a rather interesting equation, but you can plug that equation on Desmos literally, and you would get this equation. Very awesome. So you may want to jot down some notes for homework, but really we're just going to explore today, and we'll formalize and practice tomorrow. So we'll formalize everything tomorrow, but we're just going to primarily go through some exploration, I guess, today. Make sense? Okay. So polar graphs. If I click on the next one, what does A do? What does A do? So I have a basic cosine graph, A cosine. And so I just kind of play around with it. What does it do? Okay, so it kind of looks like a circle, and then when I go from the negative side, it flips, right? It goes into the negative almost realm, as it were. So play around with that, and then go to the next slide and just say, you know, hey, what is it about? Kind of explain your idea of what did the A do when I manipulated the A? What did it do to my trig function, my polar equation? Okay, and then this one, you're going to just try to type a similar equation. See if you can actually write this equation, what you see on this graph. Okay, it can be anything, but it should be correct. So really, it can't be anything. My bad. So I'm going to start with R equals, and I notice that that 3 there. Notice that 3. What if I just type in 3 and then cosine theta? Is that my actual answer? I don't know. So see what you can do. Go back, if you need to go back and kind of go to the second slide to just kind of play around with it. If you need to go back and just play around with it, but notice when I put 2 here, where did it head to? 2. If I do 10 here, where does it go to? 10. So when you're going through your quick check, do you think this would be correct? I probably think so. All right. Now do another quick check and see if you can get this one. Remember, what happened when you flipped it? Was it negative? It's positive? Try to see if you can do that one on yourself. I'll give you a hint. It's going to look something like this. Cosine theta. Whoops. And there's one little thing that's missing right there where my cursor is. One little thing. See if you can get that. All right, now you're going to go to 6, and you're just going to basically go through and do something similar with A, but now with sine. So not with cosine, but now with sine. Now, what's the difference between cosine and sine? Notice how cosine was on the x-axis, where sine is on the y-axis. And what happens when I change it to negative? It goes into negative. What happens if I'm at 2 here? Or let's just say 3. Man, it's being really slow. Oh my gosh, this is being ridiculous. Really slow. what happens if I'm at 3 here? Notice I'm at 3. My circle, whatever, is at 3. So think about that. Then you're going to go through and talk about what did A do with the last graph with sine. And then you're going to go through quick checks. And it's basically going to be this same kind of repetition throughout the whole sort of Desmos activity. It is rather long because it's a lot of graphs, but I'm telling you, if you complete this, you're going to be so much better off tomorrow during the lesson. I'm going to go pretty quick through the lesson. It's probably going to be like maybe 30 minutes even, not even that. It's going to be very quick. So now you're going to be comparing the sine and cosine graphs and see how they relate to each other. Okay, so go through those slides. How are they different? How do they relate? And then you're going to get to slide 12, and then what we call roses. Okay, it's basically roses. All right. And so you're going to look at, okay, what if I have 0? What if I have 1 here? What if I have 2, 3? It doesn't matter. What does the A do? And then what does this N do? If this is my formula and N is times my theta, what does my A do and what does my N do? So let's change this to like 4. Whoa. So it was 3, but now 4. How many is this? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if it's 4 and then there's 8, that's interesting. 5, okay, it's just 5, I guess. But then if I change it to 6, oh, geez. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What's the relationship here? What's the relationship? Think about it. And then go on to the next one and see if you can continue it out. Like see what the differences are between each of these. So if I make them negative, if I just have 3, and then if I make that a negative as well. See what the differences are, and then you're going to talk about them. Okay, very simple exploration, very chill. Okay, I think it's actually a rather great Desmos activity. You're going to continue going through those until you get to what we call petals. So what are the petals of sines, and how can I actually determine the number for the petals of sines? Go through it, and it should be very obvious, but you have to be thinking. You have to kind of think about the relationship between the numbers and then the petals. You have to think about the relationship between the numbers and the petals. So I'm going to skip a lot of these. That's okay, but think about it. Play around with it. See where you're at if you're given a certain number, like even for 15 here. If you're given a certain number for 2, how many petals do I have? But what if I have just 3 here? What do you notice? It's almost as if it's even, it will be double. But if it's odd, it will be the exact same number. Think about that. Think. So go through these and actually think. That's what I want you to do. Explore it yourself. Okay? Then you're going to have a quick check using that knowledge. See if you can actually get these. Okay? And use your classmates to help you. Like use what they say to help you if need be. You're going to go through a ton of quick checks for the petals. I have tons of quick checks for you. I don't expect you necessarily to go through every single quick check, okay? But I think it would be helpful for you to just kind of be very, very familiar with these graphs because these are actually very, very easy mathematics. They're not complicated at all. You just need to think about the relationships between sine, cosine, and then the petals, the polar equations, and so forth. You're going to go here and notice and wonder. What do you notice? Write down something that you notice and something that you wonder. It's an awesome avid strategy that we're going to be utilizing here. What do you notice and what do you wonder here? Continue on, and then you're going to be doing what we call cardoids. All right, these are rather odd. All right, but cardoids, and look like little. They look like something. Let me just say that. Play around with it just the same and see what you get. So notice how you get a loop eventually in here, and you get a circle. Pretty cool, right? But then you start kind of getting more of a loop. Very, very interesting indeed. And also notice how I'm on a rectangular plane and I still I can get that. Like I'm on a rectangular plane, but it's still like that. You can always change it to, a polar plane. It does not matter. And boom. Okay, play around with it. Then you're going to go to the next example. You're going to kind of select each one, see which one is which. There's a lot of stuff happening here. Kind of play around, see how each one kind of differs and how do they differ. And then you're going to get into analyzing what we call the loops and then the quick checks, okay, at the end. All right, loops and then the quick checks. Make sure at the end you actually do give some feedback. That would be very, very helpful. I would love that. Okay, and enjoy it. It shouldn't take too long. It should probably only take about 30 minutes. But think about each question, and I'm not looking for anything specific. I just want you to kind of explore and enjoy. Okay, so that is the polar graph explorations. Polar graph explorations. There is no homework other than just Math Excel. You can get a jump start on 7.4 in the video, I suppose, if you want to. It should be very, very short. But until next time, guys, this is C Squared Mathematics. See you guys later.